Hello students, I am Dilip Udami, Assistant Professor at LJ Institute of Engineering and Technology. In Fourier series, today I will teach you how to find out the Fourier series of functions of period 2L when the period 2L is divided into two subintervals. So let's start. So first of all, we will see how to find out the Fourier series of functions of period 2L. Let f of x is a periodic function with period 2L in the interval c to c plus 2L. Then the Fourier series of f of x is given by f of x equals to a0 upon 2 plus sigma n is from 1 to infinite an cos n pi x by l plus sigma n is from 1 to infinite bn sin n pi x by l, where a0 equals to 1 upon n integration from c to c plus 2l fx dx, an is 1 upon n integration from c to c plus 2l fx cos n pi x by l dx, and bn is 1 upon n integration from c to c plus 2l f of x sin n pi x by l dx. Now we will see one example related to this topic. Example number 1. The Fourier series of the periodic function with a period 2 of f of x equals to pi when x is between 0 to 1 and it is pi into bracket 2 minus x and x is between 1 to 2. Comparing 0 to 2 with 0 to 2l, we will get 2l equals to 2, so we have l equals to 1. The Fourier series of f of x with period 2l is given by f of x equals to a0 by 2 plus sigma n is from 1 to infinite an cos n pi x by l plus sigma n is from 1 to infinite bn sin n pi x by l. So a0 by 2 will be as it is, sigma n is from 1 to infinite, an will be as it is. Now replacing l by 1, so we have cos n pi x by 1, so it is cos n pi x plus sigma n is from 1 to infinite bn. Again here replacing l by 1, so we have sin n pi x. Now we will find out the value of a0, and a0 equals to 1 upon l integration from c to c plus 2l. Now as you can see that the interval is 0 to 2, so definitely the value of c will be 0. So in this integration we will replace c by 0 and l by 1. So we have 1 over 1 integration from 0 to 2 f of x dx. Now the function is defined in two intervals, one is from 0 to 1 and other is from 1 to 2. The function is not defined in the interval directly from 0 to 2. So we will write down integration from 0 to 2 f of x dx as integration from 0 to 1, and in the interval 0 to 1 we have f of x equals to pi. So it is integration from 0 to 1 pi dx plus integration from 1 to 2, and in the interval 1 to 2 we have f of x equals to pi into bracket 2 minus x dx. Now we will find out the integration of pi and integration of pi into bracket 2 minus x. So pi is a constant value. Now integration of 1 with respect to x, answer is x, and the limit is from 0 to 1, pi will be as it is. Now for the second term, pi will be as it is. 2 is constant value, integration of 1 with respect to x, that is x. Then after minus integration of x, according to the formula, integration of x raised to n dx, that is x raised to n plus 1 upon n plus 1. So it is x square by 2 and the limit is from 1 to 2. Now we will apply first upper limit 1 and then after lower limit 0. So taking pi common, so it is for upper limit 1 it is 1 and lower limit 0 it will 0, so 1 minus 0 is 1. Then after for upper limit 2, it is 2 into 2, 4. Then after minus 2 square by 2, so that is 2. Then after for lower limit 1, it will be minus 2 into 1, so that is minus 2. Then after minus minus plus, 1 square is 1 and divided by 2. Now 4 minus 2 will cancel out. So it is 1 plus 1 by 2. So that is 3 by 2. And if you will multiply 3 by 2 by pi, you will get 3 pi by 2. So this is the value of A0. Now we will find out An. And the formula of An is 1 over L integration from c to c plus 2L f of x cos n pi x by n dx. Now in this integration we will replace c by 0 and L by 1. So we have 1 over 1 integration from 0 to 2 f of x cos n pi x dx. Now we will write down this integration as integration from 0 to 1, and in the interval 0 to 1 f of x is pi cos n pi x dx plus integration from 1 to 2. For the interval 1 to 2 we have f of x is pi into bracket 2 minus x cos n pi x dx. Now we will find out the integration of cos n pi x and integration of 2 minus x into cos n pi x. Now this pi will be as it is a constant value, and integration of cos n pi x, that is sin n pi x divided by n pi, and the limit is from 0 to 1. Now this pi again it will be constant. Now we have to find out the integration of 2 minus x into cos n pi x. So to evaluate the integration of this function, we will apply Bernoulli formula. So first function, that is 2 minus x, will be as it is. Then after we have to find out the derivative of this function. 2 is a constant value and its derivative will be 0. Minus derivative of x is 1, so we will write down minus 1 over here. Then after we will integrate cos n pi x. Integration of cos n pi x is sin n pi x upon n pi. Now integration of sin n pi x upon n pi. So it will be minus cos n pi x upon n pi, and this n pi will be as it is, so it will become n square pi square. And then after we have to keep alternate sign. So for the first term we have positive sign, and then after for the second term we have negative sign, and the limit is from 1 to 2. Now we will apply upper limit and lower limit to simplify this result. If we put down the value of x equals to 1 over here, so it will become sin n pi, and the value of sin n pi is 0. And for the lower limit x, it will become sin 0, and the value of sin 0 is 0. Now for upper limit 2, if you replace x by 2 over here, so 2 minus 2 is 0, so this sum will become 0. And for x equals to 2 over here, it will become cos 2 n pi over n square pi square, and the value of cos 2 n pi is 1. Then after for lower limit 1, this term sin n pi will become 0, and for this term it will become cos n pi, and the value of cos n pi is minus 1 raised to n. So we will be having two terms after simplification of this expression, and that is an equals to minus cos 2 n pi upon n square pi plus cos n pi upon n square pi, and you have to write down this reason, that is sin n pi and sin 0 both are 0. Now the value of cos 2 n pi is 1, and the value of cos n pi is minus 1 is to n. So taking n square pi common, so we have 1 over n square pi into bracket cos n pi is minus 1 is to n minus cos 2 n pi is 1. So this is the value of an. Now similarly we have to find out dn. So this is the formula of dn, that is 1 over l integration from c to c plus 2l f of x sin n pi x by l dx. Now replacing l by 1 and c by 0, we have 1 over 1 integration from 0 to 2 f of x sin n pi x dx. Now we will write down this integration as integration from 0 to 1, and in the interval 0 to 1 we have f of x equals to pi sin n pi x dx plus integration from 1 to 2, and in the interval 1 to 2 we have f of x equals to pi into bracket 2 minus x, and sin n pi x dx will be as it is. Now we will find out the integration of sin n pi x. So pi is a constant value. Integration of sine n pi x is minus cos n pi x upon n pi. Now to find out the integration of this term, we will apply the Bernoulli formula, right? So that is pi will be as it is, and integration of sine n pi x is minus cos n pi x upon n pi, and the limit is from 0 to 1. Pi is a constant value. Now applying Bernoulli formula on 2 minus x sine n pi x dx. So 2 minus x will be as it is, derivative of 2 is 0, then after minus, derivative of x is 1, so it is minus 1. Now integrating sine n pi x, so it will be minus cos n pi x upon n pi. Now again integrating minus cos n pi x upon n pi, so minus sign will be as it is, and integration of cos n pi x is sin n pi x upon n pi, but already over here we have n pi, so it will become n square pi square, and we have to keep alternate sign. So first term is positive and the second term is negative, and the limit is from 1 to 2. Now we will apply upper limit and lower limit to simplify this result. So this pi will be as it is. Now for the upper limit 1, it is minus cos n pi upon n pi. Then after for lower limit 0, it is minus minus plus cos 0 divided by n pi. Then after plus, this pi will be as it is. Now for the upper limit 2, so first term is 2 minus 2 0, so it will be eliminated. Then after for the upper limit 2, for this term, it will become sin 2 n pi, and value of sin 2 n pi is 0. So again this term will be eliminated. Then after for the lower limit 1, 2 minus 1 is 1, and if you will replace x by 1 over here, so it will become cos n pi, and already we have minus sign outside, so it will become minus minus plus, so the result is cos n pi upon n pi. Now for this term, if you replace x by 1, so it will become sin n pi, and the value of sin n pi is 0. Now we have to simplify this result. So this term minus cos n pi divided by n pi and cos n pi divided by n pi will cancel out. Now if we multiply pi by cos 0 by n pi, so pi will cancel out, and the value of cos 0 is 1 divided by n. So this is the value of Bn. Now, hence the Fourier series of the function in the interval 0 to 2, that is f of x equals to a0 by 2 sigma n is from 1 to infinite an cos n pi x plus sigma n is from 1 to infinite bn sin n pi x. Now value of a0 is 3 pi by 2 divided by 2, so it is 3 pi by 4 plus sigma n is from 1 to infinite, and the value of an is 1 over n square pi into bracket minus 1 is 2 n minus 1 cos n pi x plus sigma n is from 1 to infinite, and bn is 1 over n sin n pi x. So in this lecture we have discussed how to find out the Fourier series of the given function f of x in the interval 0 to 2l when the interval is divided into two subintervals, and examples related to this topic. Thank you for watching this video. I will see you in the next lecture.